Medium to large office connections, configuring digital interfaces. Alright, we are about to get into some pretty heavy concepts. We're going to go through and start setting up our router to connect to PBX systems and route that traffic across the IP WAN. Most people call this toll bypass. So we are going to hit some pretty huge concepts in this section that will continue to bleed over to many other videos as we talk on about how we can tweak this and make it more efficient and ways to optimize our connections. So what we'll walk through is, first off, the digital foundations. We'll take a look at, for those of you that haven't configured a digital interface like this before, what are some of the primary things that we need to do to get it up and running. From there, we'll look at the initial CAS digital configuration. This is channel associated signaling, so that means we don't have any dedicated signaling channel. We'll then take a look at CCS ISDN configuration. This is common channel signaling, so that means we've taken one of our B channels and completely isolated it for signaling. In the ISDN world, we call that our D channel. We'll then look at the huge concept of the day, and that's transparent common channel signaling. This is the concept that allows us to take PBX signaling and transfer it over an IP WAN. I know that sounds pretty vague right now, and I'm keeping it vague because there's a lot we need to talk about when we get into transparent CCS. Well, let's start off with the foundations of digital interfaces. If you haven't configured a digital interface before, these are your three things that have to be in place before that digital interface will work at all: the framing, line coding, and clock source. Now, these will typically be provided by the service provider. Framing, you'll just type in what they tell you to type. Line coding, same thing. And the clock source is where you're getting your clocking from. Most of the time, that will be the line. So let me bring up a router that has a digital interface in it and walk through this configuration with you. Now, this is a very special router. This is a router I just got not too long ago. It's one of the 2800 series. If you took a look at the nugget on what routers are able to do this, the 2800 is a brand new series. This is actually a production router. It's running Call Manager Express for my company, and it's running IP phones in the background as well. Let me do a show voice port summary just to get you familiar with this router, because we'll be on this one for quite a bit. Now, the show voice port summary shows that we have a 4-port FXO card coming in there. That's connected to the public switch telephone network and is receiving calls on the lines and routing them to internal IP phones. Now, this is running Call Manager Express, which is way outside the scope of this course, but essentially Call Manager Express allows a router to run your IP phones inside of your company. And you can see that we have these eFXS ports. Now, I know you know what FXS ports are, but eFXS ports are virtual FXS ports that this router will create for the IP phones. For example, I have an IP phone sitting right next to me. Let me just go ahead and lift the handle off hook. And you can see that right there we have two of those ePhones that just went off hook. And the reason why two went off is because this phone has two lines and both of them became active. So these eFXS, you don't even need to worry about those for right now because that is getting into the Call Manager Express side of the world. Now, this router does also have a digital T1 interface inside of here. And notice it doesn't show up in the show voice port summary at all. I'm going to type in a show IP interface brief, one of my favorite commands. And you can see I don't have a digital T1 interface here either. I have the fast Ethernet 0 and the service engine. That's because this actually has a Unity Express card inside of it for voicemail. But those, I mean, we see no T1 controller at all. Anytime we're talking about T1 controllers, we're going to be looking at using the controller configuration mode itself. Watch this. I'm going to type in show controller. Actually, let me clean up that slide in the background. The lines are bothering me. All right, we go up there and we type in show controller followed by T1. Now I hit enter and I can see that right now I have a T1 controller and it's in this strange modular syntax. It's module 0, module 0 is the router itself. It's installed inside of the router because this router can accept voice cards natively. We have module 1 inside of that module and port 0. So this is kind of like unit, subunit, port. And I see right now it is down, and it will stay down because I don't actually have a production PBX to connect this to, but I can show you the configuration. The first thing that we're going to do is get into global configuration mode. And from there, I can type in controller T1 and then the slot subunit and port number. So I type in 0/1/0 and I'm now under T1 controller mode. Now the first thing I need to set up is my framing. I'm going to type in framing followed by SF or ESF. Now you can really get deep into how these work, but these are really the ways that we frame our bits when we send them across the T1 line. The older way, SuperFrame, took 12 frames at a time. It's kind of like a time chunk, and sent 12 frames. Extended SuperFrame sends 24 frames at a time. It's a little more efficient than SuperFrame, and just about all the service providers nowadays use ESF as their framing type. So we'll type in ESF. Again, just what the service provider tells us. Now we'll then type in our line coding. Again, this will be just what the service provider gives us. Now if we have a digital connection in the United States of America and sometimes in Japan, you'll be using B8ZS. I've configured a ton of these, most of them in North America, and I have never seen anything other than B8ZS. The only time I've seen AMI is if you're in Europe. Europe connections will use AMI coding. So I type in B8ZS, again, just what the service provider told me to do. The final one will be the clock source. Where do you get your clock from? Now you see right here we have a few options. First off, let me start from the bottom. Line is the most common and is the default. If I type in line, it's going to get the clocking for the line from the line itself, meaning that the service provider is giving you the clock. Now the internal clock is typically used if we want this to have an internal basis, meaning it is providing a clock for another routing. Let me get back to my slide back here and give you an example of this. Maybe I have a router and it's connected to the PSTN right here, and it is also connected right here to a PBX system. Now I have a WAN link just because I'm using a T1 card, but really, I mean, that could be 3 feet away. That's just a T1 line connection. Now we could be receiving our clocking from the line on the T1, and then we could provide the clocking on the T1 interface to the PBX. And so we would use an internal clock right here and provide the clocking this way. The PBX would receive the clocking as it believes we are the PSTN. We're kind of a proxy sitting in between, because maybe we route most of the traffic across the IP WAN and use the PSTN as a backup connection. So that's where our different clock sources come in. Now a free running clock just is kind of like free as a bird, the Beatles song comes in. I don't know why. This is just a clock that just runs at will. This is typically used if we have a T1 line that doesn't really go anywhere. We're not really providing the clocking to anybody. We're just kind of letting the clock run as it will, not really synchronizing with anything. So in this case, most of the time we'll type in clock source line. Now there is no shutdown command for this. So at this point, our controller is set up with the foundation commands to get it up and running. Now that we have the base configuration laid down, we can start configuring the groupings of our DS0 channels on our interface. I want to make sure you guys have this concept before I get into the configuration. We're sitting right here on this router that has a connection to a PBX over here. Maybe that's a T1 line. Oh, let me get a different layer here. That's a T1 line. Connection to the PSTN, maybe that's a T1 line, and then maybe a frame relay connection over to the IP WAN out of standard serial interface. Now when you sign up for a T1 connection from the PSTN, a lot of times they don't see it as a T1 line. Sure, you're going to get a wall jack sitting in your business, and it'll have a little plug right here with an RJ48 plug that looks familiarly like a Cat5 connection, and you'll run that into your router. But that plug, that little cable that's bringing in there, while they call it a T1 line, a T1 is just a logical expression for a group of 24 DS0s. Okay? Now a DS0 is just a single channel of 64 kilobits per second. So we really build our T1 lines with 24 of these little guys, and so you really think of this as 24 individual connections. Now those 24 channels are yours to play with. They're at your disposal. For instance, I could have, maybe just paying a fractional T1 cost. Well, they still bring in a T1 interface. We just need to provision this line to only use part of those DS0s. Before, back in the day, we used to have these CSU DSU boxes. And I shouldn't say back in the day. Those things are still all over the place. CSU DSU. And that would be configured by the service provider to do the provisioning for us. Meaning we would just plug a serial connection into that, and the service provider would make this little widget do all the provisions, so you would only use the first 12 DS0s, and that would be considered a fractional T1 line. Or you could get a full T1 line from a service provider, and you could say, I want the first 12 channels to be data channels. So those will go into my router and maybe connect to a WAN link somewhere else. And the other 12 channels will be used for the PSTN. That will be used for voice. Well, they would take a multiplexer, or a splitter if you will, or a demultiplexer, and split that out from the CSU for one going to the router, one going to your PBX, and this would configure what channels go to what device. I know I'm starting to get kind of sketchy here with my drawings, but we need to, on our router, do the functions of the CSU DSU. The reason why is because all modern interfaces, if you look at them, let me see, matter of fact, let me see if I can find it. Right here, let me scoot this right back into the window here. You see this, it's really hard to see, but it says T1 CSU DSU. Let me, enlarge this little box right here. That actually says T1 CSU DSU because that functionality of that external box has been squished into that interface of our router. So now we do the provisioning on our router. So, that being said, let me bring our router right back up here, and let's set this up to do the provisioning. The way we do this under the controller mode is we set up something known as a DS0 group. Now remember, we are configuring a CAS style connection. You can see it says this is a replacement of a CAS group. It used to be called a CAS group. Now we call it DS0 group. So I'm going to type in DS0-group, and there's going to be a whole lot of, it's one line of syntax and a whole lot of ramifications. And it comes up and says, what group number do you want? We can take our DS0 group into, or we can create up to 24 DS0 groups, 0 through 23, that splices this T1 line into 24 different groups. Back to the whiteboard. Let's talk about this. A DS0 group is kind of like this concept right here, where I took that CSU DSU and split it into two groups of DS0s. I have 12 of them that are going to go to data connectivity, and 12 of them are going to go over here to the PBX system, and that'll be used for voice connectivity. So I don't have to, create 24 different groups for all 24 channels if I have a full T1. I can group together 12 channels into one group and 12 channels into another group. As a matter of fact, it's really rare that I would actually splice each DS0 into its own group. It's kind of inefficient. So I would type in DS0 group, and I'll say 0. And then I'll say time slots, and it says, okay, what time slots? What do you want to carve out of that line? What do you want to group together? So I'll say, you know what, I'm only paying for a real small fractional T1 line, so I'll put time slots 1 through 2. Okay, I only have 2 DS0s on my fractional T1 that I want to use for this. And then from there I'm going to say the type, hit a question mark, and this is where the huge concepts begin. Now remember, with CAS signaling, we include all of our signaling into the same channel as our voice data. So this is the types of signaling that can be squished into our same voice channel. I can use ENM. I can use FXO loop start. I can use FXS ground start, FXO ground start. You see these signaling, and immediately, I know when I first saw this, I was like, what? What? You're crazy. FXO. That's an analog port type. FXS, whoa, that's analog signaling. ENM, that's a type of analog interface. I started freaking out. They had to call paramedics and so on because this threw my mind for a loop. I thought, this is a digital connection. What are we doing using this analog signaling for digital? Well, the truth is that by using CAS-style connections, we're actually grouping a bunch of analog style interfaces, I should say, into one. See, let's imagine that I'm sitting on this router. This is my 2801 router. It's not really imaginary. I'm sitting on it. And imagine that T1 line is connected to a PBX. And I only want to use those 2 channels, time slots 1 through 2, for this PBX. Because maybe maybe that's all I want to use. I can't think of a good reason to do that. But I only want to use 2 of those channels. Or maybe on this side, I only purchased a fractional T1 line, so I only have 2 channels at my disposal. Well, when I do that, I don't have a separate channel for signaling. So I need to communicate with the PSTN. I need to negotiate with them and say, PSTN, I want you to use, FXO loop start signaling for my 2 channels, or FXO ground start. Or if I'm connecting to a PBX, maybe that PBX will be configured to communicate using FXS signaling. Or even more common is the ENM signaling that I use. ENM signaling is typically used on PBXs when you're using digital connections, and you will just use whatever ENM signaling is used on the other side. So if this T1 is connected to the PBX and it's using ENM immediate start signaling, I just type in there ENM immediate start. At this point, I'll hit a question mark. I know I'm starting to get off the screen, but hit the question mark, and I accidentally hit enter there. But it says, do you want to use DTMF tone signaling or just use ENM to transfer your digits? I'll talk more about that later. But I want you to notice when I hit enter right here, it says, whoa, configure network clock participate on WIC1 first. This is a new thing that Cisco's introduced. You actually need to go into global config mode and type in network clock participate, and then what WIC module needs to use that. And this is the WIC1 module. Now, it's odd. I'm not too sure why they did this, but they disabled the ability for WIC cards to participate in clocking, meaning receive the clocking from another device until this command designates that that WIC card is allowed to. By default, that line, like that by default, that WIC card can only receive clocking from itself. It can be the clocking source, an internal clocking source. So before I can use that command and set the time slots and start splicing them up, I actually need to turn on the clock participate so it can receive the clocking from the line. So now I hit enter, and that command goes through. Now here's the wild thing. Check this out. I love this. I go back here. I type in show voice port summary. Now remember, this is the same command I typed in when we first got on this router. Let me scroll back up. All the way back up. Right here. I typed in show voice port summary when we first got on here, and I showed you that we had FXO ports, some eFXS for my IP phone since this is running CallMagic Express. But now watch what happens. Whoosh, come back down here, show voice port summary, hit enter. Wham! Amazing! We got these voice ports out of nowhere. We've got these ENM immediate start signaling ports that just magically appear. And these are the voice ports that will now start communicating to the PBX. Now think big picture here. This PBX will now be able to send, or, well, I guess ENM, we're only communicating with the PBX. That PBX will now be able to send 2 voice calls over to our router. Now, this will require that PBX administrator, let me get back to my slide, that PBX administrator come in there and configure that PBX to only use the first 2 channels of that T1 line. And they'll have to set up a dial plan and so on to say, for instance, all PSTN calls are sent out those 2 channels of the T1 line, and our router can then send them out to the PSTN. Or route them across the IP WAN if we're trying to get free long distance. But that allows that PBX administrator to do that. Now, this brings up a point I want to talk about. This will require a PBX administrator. I've been on to all too many calls where I go out there, I get this router all up and running, I do my magic, I do my DS0 group, and everybody's like, hey, we're going. And I say, okay, where's the PBX guy? We all kind of stand there and stare, blink, blink, eyelids. You actually hear them blink in those moments, blink, blink. They look at me and they go, we thought you were the PBX guy. What do you mean the PBX guy? And I said, no, I'm the voice over IP guy. I don't do PBX systems. There's somebody that had to set this PBX up initially. And they blink at me a little more. And they go, he doesn't work here anymore. And we go, oh, well, we better get on the phone. Because, PBX systems are as diverse as the sand on the seashore. So many different configurations, so many different standards. And for me to sit there and figure out a PBX is going to take far longer than it takes to call somebody. So a lot of times you will be working with a PBX administrator as you set this kind of configuration up. You're going to do the voice over IP side on the router. They'll do the PBX side and provision that side of things. So it's really not that bad to set up a CAS connection itself. Now, mind you, we haven't gotten into any of the dial plan, the dial peer side of things, and we'll get into that a little bit later in this video. But I want to just do this one more time and show you what it would be like if we were to set up a connection to the PSTN. I'm going to go under controller T1 1 or 0/1/0, which is my T1 controller. You see that right there. And I'm going to type in new DS0 group and remove that DS0 group I just created. And I'm going to create a second one. And I also want to show you something that's a pretty big deal. I'm going to type in DS0 group and a group number. Now, just so you know, you notice up here I have port 0/1/0:0. This 0 is actually your DS0 group number. It's just a logical number that we can use to refer to that group of ports or that group of lines. See, wow, man, I have so much to talk about, guys. What we're going to have is a real messy slide to work with. Let's say that we had, let me just try and clear off some of this, whatever my undo buffer can remember. There we go. We've got a router here that is going to be connecting to the PSTN. Okay, and let's say we purchased a full T1 line, and I've got this 2801 router that I purchased just stock from Cisco. That's what I'm working with right now. Now, it takes work to actually take analog voice from the PSTN and convert that to voice over IP. I mean real work. I mean processor power. And Cisco said, you know what? This takes so much work that we can't dedicate our processor inside of this router to actually do it, because that will affect the whole performance of the router itself. It'll slow down. It'll not perform well. So they came up with this concept, and I've mentioned this before in some of the previous videos, but this concept called DSPs, Digital Signal Processors. And what DSPs do is they actually take some of the load off the processor, or I should say all of the load off the processor, for converting voice from analog over to digital or to voice over IP formats. So the reason when I did this I created such a small DS0 group of just 2 channels is because my 2801 router just doesn't have enough DSPs to run all of these FXO ports, because that takes analog to voice over IP conversions, right? Those are connected to the PSTN, and to do T1 lines on top of this. Matter of fact, let me show you. I'm going to type in DS0 group followed by a group number. Oh, and I was also talking about this group number too. This group number, sorry for my scattered mind. This group number is right here. It's just a logical identifier to identify this T1 when we start setting up our dial plans. For example, I can say all numbers that deal with PSTN digits go out this port. And it's the same port with multiple channels inside of it. So it will send it out the port. If channel 1's in use, it'll go to channel 2. Channel 2's in use, it'll fail over to channel 1. If they're both in use, you'll get a busy signal. But now back to my point. I was typing DS0 group. Let's use just group 1. Or let's get wild. Let's use group 10. It's just a group number. Just identifies that group. I'll type in time slots, and let's say I purchased and provisioned a full T1 line from the PSTN using CAS. Watch what it's going to do, because, mind you, my router does not have enough DSP resources to do this. I'll say I want to do 1 through 24. And then it says type of signaling. Well, if I'm connecting to the PSTN, most of the time I'm going to use FXO loop start. That's just what the PSTN will use most of the time to connect to my router using a T1 interface. I'll hit enter. Watch this. Comes up and says, whoa, let me scoot this over so you can see the whole message. I'll read it to you. It says, not enough DSP resources available to configure DS0 Group 10. The remaining DSP resources are enough for 4 time slots, meaning that this router standard comes equipped with enough DSPs to run, because I have 4 analog ports plus 4 more time slots. And I tested this before I did this recording, and I yanked out my FXO ports when I wasn't in the production time frame, and did this command again, and it jumped up to 8 time slots that I could provision for this. And it says, for the current codec complexity, 2 extra DSPs are required to create this voice port. So it even does the math for us. And it tells us, you need to go to Cisco and give them enough money that they will ship you 2 additional DSP chips. Now these are just chips. I mean, you literally open up your router and install these chips inside of your router, and that will give you the resources that you need. So in this case, instead of provisioning the whole T1 line, I'm going to say I want to provision time slots 1 through 4. because we had budget cuts and couldn't get a whole T1 line there. It's the same concept, though. It's just how many DS0s you get. So I type in FXO loop start, enter. I am done. That now brings up my CAS connection. I'll type in show voice port summary. It brings up my CAS connection to the PSTN, and you see that I now have port 0/1:10. Notice that's my group number, channel 1, 2, 3, and 4. 4 more FXO ports that have just appeared on my router. Now let me remind you again, I am setting up the physical CAS connection. I haven't set up any dialing patterns at all. Meaning, I can't dial the PSTN from, say, an FXS port or somebody coming from the PBX going to the PSTN. This router is dumb. It doesn't have anything more than a physical connection. But, believe it or not, as of right now, I could start, having calls come into my router on those provision lines. Physically, the connection is there. It's just I have no logic behind it. We'll get a little bit into creating the logic for the connections later on in this video, but there's going to be an entire video focused on nothing but advanced dial peer configuration. That's going to be huge. That'll be where we configure the dial plans and all of the logical routing table for our voice network. So now we've turned from our CAS connection, our CAS style connection, into the common channel signaling ISDN. This is the first style of ISDN connection that we'll have. Now a lot of times this can exist between the router and the PBX if the PBX has an ISDN interface. This could be, PRI. Or this could be, and my PSTN cloud went away. If the PSTN only supports CCS ISDN connections, that could be how it's configured as well, and that'll use the Q.931 protocol that we discussed when we went through the concept section of the digital connection. That'll do all the signaling of all our caller ID and dial digits and everything like that between these different devices. But we will lose a complete B channel as it's converted over to a D channel for all of our signaling. Now I went through and removed the DS0 group from our router, and this is the same interface, same router, same controller. Those controllers can handle CAS style connections, straight T1 lines is what most people call them, or can do ISDN PRI connections with that interface. In order to do it, the first thing that you need to do is set up your ISDN switch type. So I can type in ISDN switch type, and right there I have all the common switch types that I can use. Now you see right here that I have primary 4 ESS, 5 ESS. These are a lot of the data switch types that you'll see people use. Notice that we also have one that you may have ignored if you ever saw it in the context-sensitive help before. QSIG. You may remember that from the concept section when we went through the digital concept. QSIG is actually the #1 signaling protocol used between PBXs nowadays to communicate features. So I can go in there and type in primary QSIG if I wanted to use Q signaling going across there. And at that point, it's not really even, I guess, a true ISDN configuration, because ISDN dictates you must use the Q.931 protocol. Overall, at this point, we've decided to use a protocol based on Q.931, and that's QSIG. So now we go back under our controller. I'll type in controller T1 0/1/0. That's our interface. And now instead of typing DS0 group, which splices up our DS0s, we use a PRI group. PRI being the ISDN style of connection. Now, once again, I don't have enough DSPs on this router to handle everything, but I'm going to type in PRI group and do time slots, and let's just say, well, let's use all 4. I'll use all 4 PRI connections, or all 4 B channels that my DSPs will support, and that's all I really need to type. My signaling was specified back when I did my ISDN switch type. So I don't have any signaling. These options right here, first off, if I wanted to use a call manager to control this, I would type in service MGCP, and that would allow a call manager to use this. Or if I wanted to use something known as NFASD, this is useful if I have multiple PRI channels in my bundle. If I have 3 or 2 different PRI lines, full bundle, I can use one D channel to control multiple PRI connections. So I could use, for instance, let me get back to my whiteboard here. Maybe I had 2 PRI lines going to that PBX. And you don't want to take two D channels out, because then you lose two connections, when one D channel can actually handle all of the B channels in this one and this one. One D channel can actually handle, I think it's up to, I'd be guessing. I know it's more than 64 B channels, so it's plenty that one D channel can handle. So I could create this NFAS-D, which means that I can say this is part of an NFAS group. And I could say this is the primary D channel that I want to use, and this, the PRI that I'm using on this connection will be the primary D channel, and all the others will have none, which means it's just going to be B channels. And you can specify group numbers and all that, and that's way outside the scope of this course. But I just wanted to define that for you. It's pretty cool. That is actually, just to give you an idea, that's covered in a course called Gateway Gatekeeper. It's one of the final exams for the CCVP certification. And that's actually the last course that most people will take when they go towards their CCVP. So if you want a lot of info on that, and that's one of the most intense courses out there, that is the course to take. So I type in my PRI group time slots, and whoa! Did you see all that? Status messages flying everywhere. I turned on the logging so we could see it. It actually does this for the DS0 groups. I just had the logging turned off. And now we see that, look at this. Well, let me jump out here. The status messages give a lot, but let me go back here and I'll type in show voice port summary. And I hit enter. And what we see here is I have all my voice ports. And look at this. It didn't even ask me for a DS0 group number, because all these are group 23. The reason why is, you notice, I don't know if you saw it slide by here. It might be off the screen. But you notice it also created serial ports. Serial 0/1/0:0:1:2:3. Those are my 4 voice channels. My 4 B channels that I just created. You see all those right there. But it also created the serial 0/1/0:23. This is the D channel for the line. That is the signaling channel that it's going to use when it's going through and doing that configuration. So I can even, I did show voice port summary right there, and saw all the voice ports, but I can do a show IP interface brief, and I can see these B channels and the D channel. All of my logical configuration will be applied to this one. And when we get into the dial peers and I say, hey, if they dial this number, which goes out to the PSTN or something like that, I'm going to point it to exit out this D channel, and this will be the brains behind the B channels. It's this channel right here that's going to bring these channels up, so I can go in there and say, okay, I want this :0 to go active. I want this to go active. This is the brains behind the whole operation. So all of that signaling will happen on that channel I never created, channel 23. And the last thing I'd like to talk about is something called transparent CCS, transparent common channel signaling. Now, I'm not going to go through the complete configuration, but not only because of the time it would take, but also because there's a lot of concepts I need to still fill in before I think you'll understand the big picture of this. But I do want to define what transparent CCS is all about and show you the base of what we're going to do with it. A lot of PBXs are very proprietary in nature, as almost PBX definition says. You buy a Nortel PBX, you're getting Nortel phones, you're getting Nortel cards, everything is Nortel. So a lot of times you'll also be getting the Nortel protocol that only Nortel PBXs can understand. So if you want to have a PBX linked to a PBX and say these are both Nortel PBXs, and use that Nortel protocol, because a lot of times they'll restrict it to where if you don't use the Nortel protocol, you'll lose a lot of features. Well, you'll have to look for something called transparent CCS. Here's the concept. Transparent CCS is kind of like ISDN in the sense that it does use common channel signaling, but that's where it stops. What CCS means is that we have a common channel for signaling, period. It doesn't really say what goes through that channel, it just says we have a common signaling channel. There's my channel. So in, let's say, a full T1 line, I'll have my 23 B channels, and then that channel 24 will be the signaling channel. We can configure the concept of transparent CCS on our router, and what it will allow us to do is send the signaling through the channel without even looking at it. Meaning the router will not understand what that signaling is, it will just pass it on. So let's say that we do have that Nortel PBX and a Nortel PBX over here. So we've got the two ends. And we want these two to believe that they're directly connected through a tie line, but rather than actually paying the PSTN and purchasing a tie line, because that's a pretty costly monthly fee, we want to route that over our IP WAN and kind of fake these guys out and make them think we've actually purchased a tie line. Well, the base of a transparent CCS configuration goes something like this. You're going to bring up your router connection, and I've already removed all the PRI configuration we just had a moment ago. And I'm going to go in here and get into global configuration mode. And what I need to do is I need to get under that controller. I'll type in controller T1 0/1/0. Hit enter. And now I'm going to do a DS0 group. Now I know it's kind of counterintuitive because so many times we've related CCS equals PRI, right? ISDN is CCS. But that's not true. CCS just means we've carved out a channel for signaling. So we're going to create a DS0 group, and we'll call it group 23, because all we're going to do is carve out one time slot, the 24th time slot. Because on T1 lines, it's always the 24th time slot that is used for signaling channel. On an E1 line, you're looking at the 16th time slot that you want to carve out because that's used for signaling. I don't know why they picked one right in the middle, but they did. So the 24th time slot will be used for signaling. And I'm going to hit the question mark on here and choose type. And I'm going to select this one. Look at it. External signaling. And what I've done is I've now created a time slot, or I should say my own DS0 group that points to a time slot, and I've told the router, hey, router, you're not going to understand a thing that's happening on that time slot. There's going to be junk going across where. It's Nortel stuff, right? It's junk. I'm just kidding. It's junk going across there that you're not going to be able to see or understand, so just ignore it and pass it on. That's the step one that you're going to do towards configuring transparent CCS. You're going to do that on both sides. Now I'm going to stop right there at this point because step 2 and 3 and beyond starts getting into the dial plan and the dial peers. And not only will we run out of time, but there's a lot of concepts I want to talk about that we'll get into when we get into that advanced dial peer configuration. So let's wrap things up. Throughout this nugget, we've taken a look at, first off, the digital foundations, the initial commands that it takes to get our digital lines running, looking at the framing, the line coding, and the clock source. We then got into the digital configuration. Oh, I still got my my circle around my CSU DSU. Let me get that off of there. We got into the CAS digital configuration, where we started looking at using all 24 channels and including the signaling inside of that. We looked at CCS ISDN, which is essentially the same thing, but using PRI group instead of DS0 group to do the configuration. And then we just started to scratch the surface of transparent CCS. And I should say any CCS that doesn't use an ISDN style of signaling, where we use a DS0 group and carve it out and use some other kind of signaling on that signaling channel other than our standard FXO, FXS, ENM, ISDN signaling types. I hope this has been informative for you, and I'd like to thank you for viewing.